Have you ever been keen to write a C++ game with a decent game engine? Well, stick around because I'm going to show you how to use the ORX portable game engine and just a little bit of C++. Now this is the game that we're going to write. We're going to have a UFO object that flies around the screen, picking up pickups, and you're going to have a score. There's going to be sound, there's going to be all sorts of things. Now I must admit that I've actually shamelessly pinched this from another tutorial where it's a tutorial in Unity, but I've done that because I want to have something to do a direct comparison to, and I think you'll probably see at the end of this. We like to think that the ORX portable game engine is faster than the 2D mode of Unity, and also the development time is actually faster too, we like to think. So let's get started. Now, I'm going to assume that you've already got ORX downloaded already and built and got the library ready to go. So we're going to skip all that and we're going to jump straight in. Okay, so first thing we need to do is just to open a command prompt and make our way into where ORX actually lives, where you've installed it and where you've built it. And we're going to use the command init. Now, the init command is what generates a project for us. So you can work with ORX using Visual Studio or CodeLite or CodeBlocks, various IDEs that are out there. So you've got quite a choice, and init will actually generate projects for all of them. So then you can pick and choose. So it's just init and the name of the project. And here it is generating projects for all of them. And that's it. We can close it off now. We won't need that anymore. Now if we go into the project that's been generated for us, firstly in the source folder there's just the standard single C++ file. There's also an includes folder. It's empty at the moment because that's just to allow you a place where you can drop other libraries. In the data folder we've got 3 folders. The first one being texture, and that's where you can drop your graphic images that you might want to use. At the moment it's only got the ORX logo in there. In the sound folder you can drop any OGG or WAV or MP3 files in there that you might want to use. And in the config folder you'll see we've got the data configuration files that we use in our game. In the build folder, this is where we generate, or has already generated, the various projects that you can use, like Visual Studio and CodeLite, etc., etc. These are done using pre-make under the hood. So you can see here, support for 2015 is now gone, and Visual Studio 2020 is the next supported version. This is the bin folder, and this is where our executables that are built will end up, and our libraries. So I'm a bit of a fan of using CodeLite, and rather than use Visual Studio, let's try something a little bit different and use the CodeLite editor. So I'm going to go into the build folder, into Windows, because this was built on a Windows machine, and open the workspace project. Now the project has got the data config there under the config folder, and under the source folder we've got our single C++ file. In the UFO ini data config you'll see there's things like display and the resources and our objects. And we can actually build from here and just have a look what the standard demo does. And there you have it, you've got a nice spinning ORX logo. Single object on the screen. Okay. So here you can see that we've got a scene. That's our standard scene object. We're going to get rid of that. We don't want any of the sound. We don't really need anything for our project, so we're going to rip all that out. Now here is where we actually create our first object in the game, and before it was create object scene, but we'll take that out just for the moment as well. We'll gut it all out and start. Now here is our objects that we're going to use in the game, and this is a background object that we'll use. I'll save this out, and this is going to go under the data folder and inside the textures. Strip off that little bit of extraneous stuff that we don't need in the file name. Save the UFO image. Again, we'll strip this off, and the pickup object. Strip that off and save that as well. And also a pickup sound that we'll use later on when I've already got a copy of that saved there, so we'll need to save that out. So the first thing we're going to do is create our background object, and that's what we use to place it in the background and provide a kind of a play area for our UFO to move around in. But first we're going to define the background graphic, which allows us to choose what our texture is for this object, and in this case it's going to be the background PNG that we already downloaded and put into the config folder. We're going to set the pivot to 000, so that's the center or the top left origin of the screen, and now we'll do the background object, and we'll say that the graphic is actually the background graphics section that we defined before. And we'll set the position of it into 0. Actually, I've made a mistake here, sorry. So the pivot is actually the center. So you can say that you can place the hotspot or pivot anywhere you like top left, top right, or center, or you can give it a arbitrary position. But in this case, we'll just say center. And now we're going to create this background object in our game, and this will be the first thing that we see when we load up the game. And you can see here, so that's the name, the background object. So we're calling it via the text name, and let's build that up and see how it goes. And there you go. So that's an object using a particular texture, and that'll act as our background object. So the next thing we're going to create now is the actual UFO, and this is going to be the main hero of the game. And we're going to say that this object uses a UFO graphic section, which we haven't defined yet, so we're just doing the object first, and we'll set the position to be 000. So again, that'll be the very center, but we're going to actually we've got 0, 0 as the x and y coordinates, but the z coordinate is actually going to be minus 0.1, so that's a little bit less than the 0 coordinate of the background object. And the reason for that is that this is a 2.5D engine, so objects can be layered, and you can say how close or how far away they are in relative terms to another object. So we're going to make it in front of the background object. Now we'll do the UFO graphic that the object is going to use, and the texture of that graphic is the UFO PNG that we downloaded. And the pivot for the UFO is in the very center of the object. Okay, and we'll create the UFO object so we can see it appear in the game. Now this time I'm going to assign the object to a variable, but called UFO, but we haven't actually defined the UFO variable yet. So we'll do that at the top of the screen, at the top of the page rather, as a ORX object pointer called UFO, and then we'll assign that UFO variable to be a copy of the UFO object, and run that up and see what it looks like. There you go. So we've got our UFO object now in the middle of the screen. Now by assigning that variable, we can actually take more control of that in the program. Okay, now we need to look at doing some input keys to move the object around, or the UFO around, and so we're going to do this with the input section. We've already got one called key escape, which is bound to a label called quit. So we'll just do key up, which is equal to go up. We'll use that label in the game. Key down, and key left, and key right. In this update method, we've already got some check there for checking if the quit key is active, and we act on that key by quitting out the program. So we'll just extend this, but we don't want to check on those UFO inputs if the UFO hasn't been created yet. So we'll just do an if UFO check first, and then we'll just check the ORX input is active on each of our key labels. So go left, go up, etc. But we'll just try the go left one first, and we'll just make sure that this is working, so that if the key is held down, that will print out a message key left was pressed. Compile that up. And pressing the left key, you really can't see what's going on. So that's not very helpful. And the reason for that is because we've got this set up as full page or full screen mode. Not in the normal full screen, but we've actually got a full window that takes up the entire width and height of the screen. So we'll change that by saying decoration is true, and what that does is put the Windows decorations back on, turns it into a normal window which we can then move. So run that up and just move it out of the way. So that will let us press the left key, and you can see there as we hold it down, the console is getting that line written to for debugging. So let's enable some physics so that we can act upon moving the UFO around. So to enable physics, we can add the physics section and give it some gravity. And in this case, normal gravity is in the Y direction at 980. Now for objects to be affected by gravity, they have to have a body. So we'll type in body here, and we'll say what the section is that controls the body, and that is the UFO body. Now this doesn't exist yet, so we'll create the UFO body section here, and we'll ensure that this body is dynamic. And dynamic means that it will be affected by gravity. So it's not a static object. Now every body that you define on an object can have one or more parts. It just doesn't have to be a single part. You can break up your body by little bits and pieces, and each of those pieces can act in a different way. And so we're going to call this the UFO part, and this goes into our part list. So we're going to make it a type of sphere, because we actually want it to not be defined as a box, because that'll give us some weird sharp corners out the side of it, which we don't want. And we'll also make it a solid object, so that when objects hit it of a certain type, they will collide and they'll be solid and bounce off each other or perform some sort of behavior like that. They won't pass through each other. Okay, let's try that out and see what happens. Okay, well, not exactly as expected. The gravity is working and that's great, but it's fallen straight through the floor. This is a top-down 2D game, so really gravity shouldn't be going in any particular direction. So let's change that to 0, and that means that there'll be no gravity forces pulling in any particular direction. Okay, so that's better. Now the object's not moving again, which is what we want for now. Now we can actually use the show debug value, which is under physics, to illustrate what objects have got a body and what the body part shapes are. So in this case, as you remember, we did this as a sphere, so you have a sphere surrounding the UFO, and that's sized automatically based on the width and height of our object. So that's fine, we can turn that off again. We'll use that a little bit later on in the tutorial. So now we're going to change the use of the go left, and in this case we're going to define some value of force that we're going to apply to the UFO whenever the left key is held down. So it's going to be a force in a vector of -80 on the X direction, and we're going to use ORX object apply force onto the UFO object. Okay, we'll try that out. Press the left key and, well, that's cool, it worked. The object's gone outside the screen, but there's nothing here. It's only a picture, so there's nothing real there or anything for it to collide with to stop it from moving outside of the play area. So the other thing to notice, I'm just going to press it a little bit, and notice that the UFO never really slows down. It seems to continue on its merry way forever. It's kind of not what we want either. We want it to kind of slow down when we let go of the key. First thing we're going to work on though is how to stop the object from leaving the play area, and we're going to do that by putting some walls around it. And we'll do that by giving the background object a body just like the UFO. So same deal again, the wall body will have, it'll be dynamic, and it's going to have a part list as well. But we'll start with the first part, and that's going to be one of the walls, and this will be the wall top part. And while we're at it, we might as well just say all the other parts that we're going to use. Even if the parts aren't there, it doesn't really matter right at the moment. So we'll put in the right part, the bottom part, and we'll have the left part. Okay, so we'll start with the top part. It's actually going to be a box because it's a wall, so it needs to have, sharp box or rectangular shape. It's going to be solid, but it's going to be defined. It's not going to be covering the whole object. It's just going to be part of it. So we'll say the top left area is going to be at the -400, -300, and then the bottom right of that rectangle will be at 400, -260 coordinates. And we'll switch on the debug again just so you can see what that looks like. Very handy for placement. Alright, there we go. So you can see part of the background is set up to have some collisions on it, so that's good. Right, now we're going to do the right wall, and you'll notice here that we've only got two properties here, which are the top left and the bottom right, and that's because we're using that inheritance there. That @ symbol means to inherit all the values from the wall top part, but we'll just override the values that we want to make unique. So we're still going to have a type of box, still going to have a solid object, or a solid collision area, but we are going to override the top left and top right values. So there you see, we now have the right collision area. And we'll do the same for the bottom and the left. And there you go. Okay, so if we move our UFO, well, he still passes through. So we've got collision areas, but the UFO's completely ignored them. So what's going on there? Okay, so now the reason for this is because we actually have to set up what's called mask checking. Start with a self tag for the UFO, and this can be any string. It's just something that has to identify the object to the Box 2D engine underneath. So in this case, we'll say that the self flag for this particular object is UFO, but the check mask is the list of names of objects that you want to collide with. So in this case, we want to collide with walls. Now, right at the moment, that doesn't mean anything. We have to reciprocate that with the object on the other end, like a kind of like a good relationship. So we have to say self flags for one of the walls, or in this case, the top part wall is called walls. And we'll say check mask for what it wants to collide with is UFO. Now we don't have to define that for all the pieces of the wall because of the inheritance, and that'll get copied into all 4 walls. So there we go. UFO wants to collide with walls. Walls wants to collide with UFO. I'll just fix that up there. Okay, so that worked. So setting up that relationship has now made there be a solid collision between a wall and the UFO. So we will now do the other 3 directions. So there'll be the right force and the left, up and down. And that'll be picked up by checking the values of the key labels. So go up, go down, go left, go right. There we go. So we can move the UFO around. That's pretty cool. Interesting effect now that we're getting as we strike a wall, that the whole play area starts to move. So it's kind of interesting, and we'll get to that soon. I'll just turn off the debug just for the moment and have another little bit of a look. But kind of cool. We've still got that play field moving around, which is interesting. Not expected, but interesting all the same. Now the other thing to notice, it's not very interesting the way it moves around. It just kind of, if you slide it against the wall, it just kind of doesn't really do anything. It'd be interesting if we kind of could roll against the wall and have some spin. That would be kind of nice. So we're going to use the fixed rotation of false, and so that turns off the rigid body position or rigid rotation. So I'll try that again. So it's not quite enough. So fixed rotation is fine, but there's actually no friction. So while it's fine to say that we'll allow our object to rotate against another, you still have to define a little bit of friction on both parts. So we'll do that. We'll do a bit of friction on the UFO, and we'll also do a little bit of friction on the wall itself. Okay, we'll have a look at that. Okay, give it a try. And that looks a lot better. There we go. So when we hit something, we've got this nice rotation. Which is kind of cool. Kind of easy to bash this playfield around. Also notice that, yeah, the rotation on that thing just seems to go forever. So what we'll do to fix it, let's just get this wall body, turn the dynamics off. And there we go. That fixes that problem. So we still got this problem with the UFO. A little bit of rotation against the wall, it'll just keep spinning forever, which is not overly natural looking. So we need to, a little bit like we did with the fixed rotation and friction, we need to do what's called angular dampening, or damping, and give that a bit of a value too, and we'll try that out. So damping is a way of slowly putting the brakes on something and having it slow down for rotation. Okay, now movement. Same sort of deal. Just like angular damping, our linear movement will go on forever. So again, similar deal, linear damping, and let's try that and see what that looks like. Yeah, that's cool. So we've got a deceleration effect, and things are looking a lot more playable, a lot nicer, a bit more natural. As natural as a UFO game can be, of course. Now, one of the nice things that it'd be really good to have is if rather than the UFO just move around the screen, it'd be nice to fix the UFO to the camera and actually make it look like that the playfield is actually moving around us. And in order to do that, we need to get some control of the camera itself. So in order to do that, we need to actually get camera out as a variable. So we'll set that as an ORX camera pointer. And we'll set the camera into that variable by getting it from the viewport, which is why viewport needed to have a local variable. And we're going to fix the camera to the UFO by setting the camera parent. And the camera is going to be parented to the UFO. Cool, so that looks kind of cool. But that doesn't look very cool. Alright, so that's a weird effect. Probably not intentional. So not only have we inherited the movement of the UFO, we've also inherited the rotation of the UFO, which is not overly desirable. So we'll change that. Okay, now what we do here on the main camera that we've used, we're going to ignore some properties from the parent, and in this case we'll ignore the rotation. Cool. Alright, that's got that fixed up. Alright, so now it's time to work on our pickup objects. And we're going to make sure that the texture that we use is the pickup PNG that we loaded from that web page before, and the pickup object is obviously using the pickup graphic. In this case, we're actually going to have several objects, and there'll be a number of them, and we're going to put them sort of in a circle arrangement. So rather than create every object, we're going to create what's called a child list, and the pickup object's object is actually an empty object that has a child list containing a bunch of single objects. And you can see here we've got the pickup object which will be inherited into pickup object 1, 2, 3, and 4, and so on. And the way we do that is just like we did before. We'll create the object from the config, giving it the name pickup objects. And that'll give us 8 of those objects on screen, as it's a container. Alright, there we go. Very cool. At the moment, obviously, we don't have any bodies or collisions or anything happening, so we just pass straight through the objects. So it would be more interesting if these objects rotated to make them sort of appealing to pick up, like they're animated in some way. And what we will use to do that, will apply what's called a rotation FX to the main object or to the templated object. So we'll do that up here on the pickup object. And we'll set an FX list, and in that list we're going to have a single FX, which is the slow rotate FX. Now, a single FX can have many items in its slot. We're only having one, and this is a looping FX, and then we'll define the slow rotation FX slot. This is a rotation type. It has a starting time of 10, a starting time of 0 and ending time of 10. It's a linear curve, which means that it's this. It's a even rotation, and the starting angle will be 0. The final angle will be 360. So that'll give us a nice, smooth rotation. You see here it's rotating slowly and nice. That's good. Okay, so the next thing for our game is to get the collision working. So we want the UFO to come around and pick up all of the little pickups, and in order to do that we'll need some way of setting up the collision. So it'll have a body as well. So in the pickup body we're going to make it, we're not going to make it dynamic, because we don't want to actually have it butt up against the pickup object and make it fly off into the distance or anything like that. We just want to neatly pass through it, register a collision, and be able to affect a change in some way. Make it a sphere. And for the UFO not only collides with walls, we now want to make it collide with a pickup as well. So we'll put that into the check mask. See with the show debug, you can see the rotation of the object, and you can see the sphere shape. So I'll turn that back off again. Now, to actually make something happen that we can control by code, we need to have a physics handler, and that's in the physics handler. That's where all the information will be discerned about what has hit what and what do you want to do when that happens. So I'll just paste in this physics event handler here, and we're going to make it a event contact add. So if there has been contact between two objects, there's going to be a recipient object, there's going to be a sender object. So we'll get in this test, we'll just get the recipient's name, the sender's name, and we'll use the log to actually output it to the screen just so we can see what has hit what. Now again, we'll set the decoration on the window to true just to make it a window that we can move around and get out of the way. And we'll see what happens. Okay, so we can see the UFO object has collided with a pickup object, and it's actually also collided with a wall, so that's good. Right, so we'll put that back. We don't need the need the window anymore, and we don't need to output anything. So what we're going to do now is that we will check the strings of the recipient names to make sure that it's a pickup object, and if it is, we know that it's the UFO that has collided with it. And if that's the case, we'll kill the recipient object by giving it a lifetime of 0, which is a very safe way of deleting an object. We also have to do the same because it could be the sender object, and if it's a sender object, that's the one we have to kill. So we'll take a look, and that's working pretty well. So as we hit the objects, they're given a lifetime of 0, which is effectively the same as deleting an object. Right, now let's add a little bit of sound. It's nice and easy to add some sound when an object is created. So, or when an object first appears on the screen, or we can make it that when an object hits something, we can actually place a sound here. So that's what we'll do. In this particular case, we'll add the object sound that we've just created in the config here. For whatever reason, if we hit the pickup object and it's the recipient, you want to actually add the sound to the sender object. So it's the opposite object, so we want to add the sound to the UFO, not to the object that we're destroying. That sounds pretty good. It's a pretty good pickup sound. Right, now an easier way to do sound is actually to do it on an object when it's created. So in this case, when the game starts up, we want a sound like an appearance sound. So we'll define the appearance sound here, and that's going to be the appear og that we have in our data folder for sound. We also want, just like before, we want to keep it in the cache so that it doesn't reload all the time. And what's going to happen here is that when the UFO object is created, that's when the sound is attached. So it's a nice easy way of getting a sound when the game is created. We could just as easily have attached it to the background object as well, and that would have been fine too. So now we need to get a score, because a game's not much of a game without a score. So now this is going to be a little bit different in that we're not going to use the PNG or anything like that. So in the case of an object that uses numbers or some kind of text, our graphic is actually going to be a little bit different. So this score text graphic that we're going to use is actually text, not an image. And so our text comes from the score text section, and that has a string of 10,000 at the moment. It could be anything. We'll just put that as 10,000. And we'll create it just like any other object onto the screen, and we'll call it score object, which is what it is in the section. Okay, so it's there. It's alright. It's just probably a little bit small. So we'll scale it up. We'll scale it by 2. You can have 2.0, you can just have 2, it's all fine. And okay, it's not bad. That's not real good though. I mean, you don't want your score scrolling around with your playfield when the playfield isn't fixed, so yeah, it's also a bit smoothish looking. Right, so what we'll do instead, let's parent it to the main camera, just like what we did with the UFO, and we'll make sure that we don't use the parent space. Alright, so that's a lot better. So now it's fixed up there on the screen, just like the UFO, and it looks more natural rather than going with the playfield. The other thing we'll do, yeah, let's turn off the smoothing. Just get that blocky look. That actually looks better. Right, now because we want to control the score, we'll need to keep track of this as a separate variable. And whenever we have the collision, not only will we destroy the pickup and make a sound, but we'll also increase that score. 150 points for every pickup that's found. Now the next thing is that we actually want to get that into an object as well, into an ORX object pointer, just so that we can control when we repaint that, that score object. So we'll need a way of taking the score variable and updating the text of the score. And we're going to do it here. So every time that if the score object exists, we'll get a formatted version of the score, and then we'll update the string of that object with that formatted score. So we're going to keep both the score variable and the score object in sync whenever there's something picked up. There we go, that's looking alright. Okay, so with all objects picked up, we've got our maximum points there of 1200. Right, so now, next we will make a you win object, or some way of saying, hey, you've done everything you could possibly do, you're the winner. So we'll make an object for that. Again, it's going to be a text object, just like what we did a minute ago. It's going to have a graphic of its own, and it'll have a pivot, and it'll have some text. And when we win the game, we'll create this object and show it on the screen. So again, we'll create it from the config. We're going to set it as a parent object to the UFO. So just like before, we'll attach that to the UFO, and we'll put it in a variable called UFO U in text object. But again, got to create that up top here. We need a pointer for that object, just so that we can control it in our code. There are other techniques for all this sort of thing, keeping objects in sync, but this is the way I prefer to do it. Okay, so that's not really what was intended. Okay, we don't want it to rotate around the UFO. Looks a bit janky. So just like before, because we're parented to the UFO, we need to ignore some of the properties from the parent, and one of those, of course, is going to be rotation, so that should hopefully fix that. Right, okay. So it's fixed one type of rotation, but not the positional rotation around an object, which is a different thing. Alright, so we'll ignore the positional rotation as well. Lots of things to ignore at the moment. But there we go, that's looking alright. No weird rotations. Of course, we don't want to start the game saying you're winning, because you haven't won. So what we'll need to do is to set, using the ORX enable function, and just affect that object by saying false. So when the game starts up, then the object will not be enabled. You won't see it. It'll look a lot more natural in a game. Okay, so what we're going to do now is we're going to check on the score, and if you've scored 1200 points, then you've won the game. So if it is, enable the object. Try that out by collecting all the pickups. Hey, there we go, we win. Right, I think it's time to do, that's kind of the basic game now, but let's kind of zhuzh it up a little bit, and we'll go back to the website and download a couple of shadows that we can use for the UFO and also for the pickups. So we'll define those two graphics as objects. So we're going to have a UFO shadow object and a pickup shadow object. So we'll do the UFO shadow object first. So we're going to have the graphic, and it's going to have use the texture of the shadow that we just downloaded. It's got an alpha of 0.3, so it's fairly transparent, and we're going to pivot it in the center, and it'll be just a bit behind the UFO, but not enough to be behind the background, so in front of the background. Now on the UFO objects, we're going to do a child list, and that's going to allow us to attach another object to the UFO, and we're going to attach the shadow. So there we go, there's a shadow. Oh, but that's not nice. That looks very goofy. So same sort of deal again. We're going to have to deal with the ignoring of properties from the parent. So again, ignore both the positional rotation and the natural rotation. That's better. Okay, that's good. Alright, now the same deal with the pickup shadow graphic and associated object. Same alpha, same deal for everything. Same sort of offset, and again we'll do it up front this time. We'll ignore from the parent the position rotation. And then we'll add that shadow object, attach it in the child list to the pickup object so it becomes attached to it. There we go, looks pretty good. That's good too. And notice that, if you notice there, as we collide with the pickup, our shadow isn't colliding. So the shadow, of course, is nothing, so it wouldn't collide physically with anything. And the same when we collide with the pickup shadow, it doesn't cause a collision. So it's only the main objects that are actually causing a collision. So that gives a more natural effect, which is nice. And that is essentially it. We've come to the end. If you've made it this far, congratulations. And you can see that working with ORX and just a text editor and just a compiler is really all you need. Once you know what the properties are and you've got those sheets that come with ORX to guide you through, play around, have fun, and I hope you enjoy writing games and playing around with ORX, and hopefully you'll come up with something pretty cool. So thanks for watching, and catch you around.